Hey guys, welcome back. In this video, I plan on covering about a machine simulation. This video will build on the earlier video that I put on about a multi-axis CNC machining. It's a long 2-hour long video that take you step by step in detail about how to set up a multi-axis machine, what to look for, how to plan the programming, because these are multi-channel machines. When I say multi-channel, it's multiple programs running at the same time. These programs work either independently or depend on each other. They run in a way of interfacing with each other. They will wait for each other. They will sync with each other. They will have a synchronized effect on the complete programming process itself. So please go back and look at the video about the CNC multi-axis program, machine setup and program. So if you look at the 2-hour long video, they'll give you a complete detail on what to expect on a multi-channel machine capabilities, because these come with a phenomenal ability to reduce the cycle time. If you select the best tooling and best possible process, that will be the optimum cycle time you will achieve in programming these parts. Okay, let's go back and look at one of the common machine tools out there for a screw type machining. So this one have a 3 different channels or 3 different mechanisms that controls how the part program is processed. Let's go back, start from the beginning. So let's start with the main spindle here. So the bar stock will be a long bar stock. Most of the companies use a 12-foot bar stock. It will be a ground bar stock, depending on the guide bushing used. What type of guide bushing used? They have from plus minus 10,000, plus minus 1,000 to plus minus 510 stock. So guide bush, then it's a main spindle, guide bushing. You have a gang tool, you have lower turret, and the back end tool. So each of them are controlled by 3 different programs. So like a 3-channel program running simultaneously. So let's go back and look at the simulation. If you want to change the view, you can go back and select if you want a different view type, you can go back and select what you want. You can go back and select the view type. You can go back and select what type of view you're looking for. So right now I selected HISO. You can go back and select this, or you can go back and select this, or use your mouse button to come back and look at what you want. Let's go back and start the simulation. Pause it. Let's go back and look at how they work simultaneously. When the turret is working, the gang will wait, or if the OD tool on the gang is turning, you can do the ID work, or if you want to do the synchronized turning, you can do that too. The last video I covered about the tapping. Obviously we did some ID thread work on it. So it's a single point ID threading. I'll cover you guys about talk you through step by step and how to program a single point thread turning. Either it's a OD turn or ID turn, ID thread turning. I'll talk about a thread milling, thread whirling. So when you look at the threads, most of the medical threads, it start with Butters threads, Acme threads. There's different IQ-lock. So those most of the threads are either double lead, triple lead. So I will walk you through how to program as double lead threads or triple lead threads. So let's look at the simulation. One critical aspect of multi-channel programming multi-axis machine is how robust is the post. Now these simulation packages are designed such that the post, when you go and post the tool path out to the control, it will simulate exactly what will happen on the real CNC machines. So if you can look at the back-end work at the same time. So now the lower turret is coming back and working on the sub-spindle. So you can see that the red is flashing. That means the holder is rubbing on the sub-spindle collet. So we need to go back and either stick the tool out a little bit longer, so give a longer overhang, or we may have to come back and do a different type of collet nut. So there will be a nice smaller profile collet nut. So one cycle is complete. Now the second sub-spindle went and spit the part out. Now the part's in the conveyor, while the main spindle is already pulled a new stock and started machining the second part. So in the future videos, we'll see how to post the tool path. Right now you've seen the tool came and pulled the bar out. Sub-spindle is coming in, holding on to the stock so basically right now that you see this operation, the training is happening between the main and sub-spindle. Sub-spindle came and hold the bar from the main spindle, thereby giving a more robust clamping for doing that side milling. Okay, like I said, it's a small video series covering on what to expect on the simulation. Thank you for watching the video, guys. If you like the content, please like, subscribe and share. That will help me build more educated content in the future. Thank you.